Assalamualaikum to all my panels, Dr. Evin and Dr. Hawani. Today I would like to present my study with the title Future Urban Growth Boundary using Logistic Regression Case Study in Seremban, Negeri Sembilan. My name is Siti Nur Amira binti Baharudin and my supervisor is Dr. Nur Hakim bin Yusuf. First of all, I will explain back my problem statement in this study. My first problem is a development beyond a city limit will create urban sprawl, where this uncontrolled development may lead to a series of problems including forest and agriculture degradation and urbanization area disturbance. And my second problem is urban sprawl has the capacity to grow in every direction, which is upward, inward and outward. Hence, to quantify the urban sprawl is problematic. This slide is about aim and objective of my study. In this study, to predict potential new city boundary and to identify the causes of suburban destruction that affect to the surrounding environment due to urban growth. Next is about my objective. My first objective is to identify the driving factor that cause of urban growth. And my research question for my first objective is what are the main factors that influence the urban to expand. And my expected result for first objective is influence level for each factor towards to the boundary growth. My second objective is to determine urban growth boundary expansion using spatial statistical method. And the research question for my second objective is what is the most efficient method to determine urban boundary expansion. And the expected result will mapping a new urban boundary. In this slide is about study area. I choose Seremban because Seremban is located in Negeri Sembilan, one of the states in the Peninsula Malaysia, located at 2 degree 43 minute 20 second north and 101 degree 56 minute 30 second east with an area of 2,980 km square. And the population of Seremban is over 500,000 and is expected to increase to 1 million by 2020. Next is Seremban city was chosen as the study area because it is the largest city in the state of Negeri Sembilan, and as a result, the town of Seremban is one of the cities to grow in the coming year. This is a map of Bandar Seremban, which is the red boundary is a Bandar Seremban. For the next is a list of data that I use in my study, which is for the dependent variable I use 0 as a non-urban, 1 as an urban. In this slide is the table of the independent variable that I use in my study. There are 16 data, then have a 4 category, which is a population in 2010, digital elevation model, public facility in 2009, and existing road network system in 2009 data. Next is about methodology in my study. Firstly is a preliminary study, which is we do a literature review. Next is a data collection. In this study, I get the two types of data, which is a primary and secondary data. Next process is a data processing. First process is a variable identification for urban boundary expansion. Second is a measure the spatial relationship among a variables data. Third is a urban sprawl prediction model using logistic regression. Fourth is a validate the accuracy of the prediction model, and the last is a mapping of a new urban boundary. Next is analysis and result. For this part, we can compute the accuracy of assessment from the result, and then we identify the new predict of urban boundary. Lastly, we do a conclusion and recommendation for this study. Okay, for this slide, I will explain a step of processing in my study. Firstly is a variables identification for urban boundary expansion. Firstly, city and non-city is used as a dependent variable. Existing city area will be assigned with a 1, while the remaining area will be set as a 0, while another 16 data are independent variable. As we can see, the image below is representing city and non-city, which is one is representing of SEREMBAN city. So next is we need to do the synchronization of the data to standardize using software ArcMap 10.3 to convert from vector to a raster data. Okay, for processing using ArcMap 10.3, firstly, I do to extend boundary of SEREMBAN to 3 km. And next is, I clip all 16 data independent to follow the size of extend boundary because the existing data is included the whole NEGERI 9. So we just focus to area of the extend boundary. Next is we do a multiple ring buffer analysis. Do a multiple ring buffer to do multiple layer of buffer for each variable in extend boundary. And next is for union tool to combine the extend boundary and multiple ring buffer output. So next is to clip the data with follow the size of extend. And lastly, we convert to raster with cell size of 13 meter. When do a multiple ring buffer, all variables are reclassified to value 1 to 5 to show that the value when 1 is does not affect, while value 5 is affect the SEREMBAN area. For next is all the variables need to convert to a raster data set to get the value in ASCII text and save ASCII text into CSV file to simplify the NumPy ordering process that involves for 3 dimension to 1 dimension. The next process is urban sprawl prediction model using logistic regression. As we know, logistic regression algorithm look at the relationship between a dependent variable and one or more independent variable and predict the probability of the outcome that can only have 2 values. So I use the dependent variable indicate the growth of the city when binary values are used between 1 and 0. To predict boundary using logistic regression, first of all, I use 1D data array that has been combining from urban and non-urban data. Then I use Python programming to create coding in logistic regression script to split the data. The function of the split is to understand the performance of the model, so need to separate the data into the 2 arrays, which is X and Y encoding. Next is to model need to fit to evaluate the information with the test set. It is important not to use the test set in the process of fitting the model. So, when we fit the model on the train set, using fit for the X train and Y train so that can get the value of the coefficient through the predictor and the response of the variable. In this slide is the next step to validate the accuracy of the prediction model. I calculate the accuracy of the prediction model using RMSE technique. RMSE can compute the difference between the actual value and the prediction value to estimate the accuracy of the prediction result. RMSE is a good measure of how accurate the model predicts to respond, and is the most important criteria to fit if the main purpose of the model is the prediction. On this slide, I will explain the result and analysis of the output that I get on this study. Firstly is a spatial variable. Urban expansion was made urban ArcMap 10.3 using the buffering tool. The expansion of the boundary has identified the maximum limit of the appropriate urban boundary extension. This is because to prevent the city from continue to develop and to cause off the connection with the other city. This boundary will extend to 3 km. Look at the picture, we can see that boundary before and after extend to 3 km. So, in this study, the predictor variable, the name given to the independent x variable used in a regression analysis, while the dependent variable y is known as a predictant. The dependent variable is a driving factor that drives urban to grow. To get the value of in binary format, all the data is converted to the raster image. The cell size used to convert to raster image is 30 meter. I choose 30 meter because when using a small size cell, the data will be high resolution and get a higher feature spatial accuracy. This is the slide show the result of the convert from vector to the raster. As we can see, there are 14 variables when red color are represented as a 5 because it is too close with the variable, while the blue color as a 1 because far from the variable. Next is a data population, when the dark brown is a 5, which means that the area has a high value of density, while the white and purple are less value of a density. Next is a DM data. For DEM data, the darkest is a higher elevation than the white color. Okay, second analysis is a regression analysis. In a regression analysis, the important things to do is to calculate the correlation between one or more input variable. First of all, I calculate the correlation between one or more input variable. Use a multi-connectivity when your model includes a variety of factors that affect not only on response variable but also each other. So in this study, I use a various inflation factor which is a VIF to compute the predictor. Look at the table. There are many variables show the value is above 5. Further, the value above 5 is represent a critical multi-connectivity stage where the coefficient is poorly estimated and the p-value is questionable. So, to interpret VIF value, the following rules are used in the table below. When VIF1 is not correlated, between 1 and 5 is moderately correlated, and above 5 is highly correlated. I do a random sample of the original 1D data for us to train the model, while the original data will be used to implement the model. Then I split the data set to train and test. Once the model is fit, you can evaluate its performance with the test set. That I use a logistic regression model to obtain the coefficient and p-value of each variable and identify which data has a p-value greater than 0.005. For train, I use a number of train set which is the 1 is urban that represent 21568 and 0 is represent non-urban, then I use 7293. 10 variables are selected after I remove the higher p-value than 0.005. They have 10 variables which is fire station, community hall, DEM, hospital, road A, bus road, mosque, health center, rail station, and secondary school. Based on the table, they have positive and negative value for coefficient. The mean of the positive value is when the independent variable increase. It makes the mean of the dependent variable also tend to be increased, while the negative value is represented when the coefficient suggests the independent variable increase, so the dependent variable tend to decrease. on the table will also get the percent of accuracy. The accuracy of the model after feed into the model is 81.32%. It shows the higher accuracy and considered as a good accuracy because we need to aim for the higher accuracy score to the prediction model. The predicted boundary happens when a predictor gives an effect to the predictant, thus making the predictor issue a new urban boundary. The image shows the result of the prediction after I view the image using Python programming in show. The result of prediction boundary is not more than 3 km from the extent boundary. It's like I show my comparison between existing boundary and predicted boundary. On the map, I overlay the existing boundary and predicted boundary. They have more different after I do overlay of both. And then in the future, we can see the boundary will be expanded from the existing boundary. For this part is about recommendation for my study. First, when use a logistical regression model to study urban growth, we must be continuous about spatial autocorrelation that often exist in spatially referenced data which violate to assumption of the model. Then can use the time series of urban growth data as a dependent variable to see the difference between years, so this study could be see a different result. For my limitation of my study is when outcome is a discrete, logistic regression can only predict a categorical outcome. Second is it can solve the non-linear problem with the logistic regression sign is a decision surface is a linear. In this slide, I will explain my conclusion of my study. First, urban growth prediction in this research is done using logistic regression model that calculates dependent and independent variable of urban growth. Second is logistic regression model has a good fit to the model with a very higher accuracy value. The outcome of the predicted urban boundary as a reference in the future to see the development of the urban was extend up not more than 3 km. Last is the result of the research will not only help urban planner predict future urban development in Seremban, but will also signal to the planner Seremban as well as other cities in Malaysia that there is an urgent need to control the relentless urban sprawl that has plagued most cities in the region that have put a significant pressure on the housing, infrastructure, the environment, causing environmental and infrastructure damage. That's all my presentation. I hope all my panel understand what I'm presenting. Thank you.